talk about a little bit the future of NASA's missions with exoplanets. So we have our upcoming mission TESS, which is going to be launched hopefully in March next year. And TESS is pretty much like the little brother of Kepler. It's a little bit smaller, but it's going to do still like very important and essential science for exoplanets. So the main reason for this follow-up mission is, so I took this picture from the website of Kepler just a few days ago, and this gives you a number of the planets, the exoplanets that Kepler has discovered so far. So we can see more than 4,000 candidate planets, confirmed more than 2,000, but on all of those, the planets with Earth size, so less than 2 Earth radius, and in the habitable zone are only 30. That's not many, right? On top of like 4,000 exoplanets, there are only 30 that can look similar to Earth in characteristics. So this is one of the main reasons why TESS was developed. I'm going to show a small short video on how TESS works. Maybe go faster. So TESS has 4 cameras, which will be aligned one on top of each other. The field of view of the cameras is going to be aligned one on top of each other.
TESS, Transiting Exoplanet Survey Satellite, discovering new Earths, super Earths in the solar neighborhood.
So yeah, here we go. Yeah, we have 4 cameras, which field of view would be aligned one on top of each other, creating the so-called sector. So all these 4 cameras will observe continuously one sector for almost 1 month. So after 1 month, the telescope is gonna switch to the next sector, so it's gonna shift on its side, on the left in this case, moving to the following sector, and so on. So in order to complete one semi-sphere in 1 year. Let me go a little bit faster. Yeah. So in this way, we can cover one semi-sphere of the sky in 1 year, and then do the same for the southern hemisphere in the second year. So we can basically see the entire sky in 2 years. So we can determine and observe, find exoplanets pretty much like around all the directions. So as we can see from this video, there are like some regions that TESS is going to observe for short time, like the equator. On the equator, the telescope is going to observe only for like 1 month, and then we have some overlapping zones closer to the poles that is going to be observed for much longer, for up to 1 year. And those are the most important part of the mission. So this red region here, observed for almost 1 year, is pretty much like overlapping with the JWST, James Webb Space Telescope Continuing Viewing Zone. So it's where this new upcoming, the kind of Hubble successor, this huge, massive new telescope that's going to be launched next year as well, is going to have its continuous viewing zone. And this is really essential because TESS is pretty much a kind of like a scope finder for JWST. So TESS is going to find the kind of best exoplanets, and then hopefully JWST is going to follow up, doing some kind of transit spectroscopy, so look at the atmospheres of these exoplanets. And this is really important because since JWST is a very demanded and many people, many scientists want to use JWST, but it's really important to optimize their observation of JWST. So from this picture, we can see that, this is a little bit shifted, I don't know why, but pretty much this kind of red circle should be centered in the sun, of course, because that's where TESS is located. So imagine that in comparison, Kepler, for example, was looking at only one kind of patch of the sky, which was very far away, 3,000 light years away. TESS is going to look at all sky with a radius of 200 light years, so very close to us. So all the best exoplanets that TESS will discover are around very bright and nearby stars. So these are some of the science goals and drivers. So mainly we want to find transiting Earths and super Earths orbiting bright and nearby stars. So and most importantly, the best means like the really characterizable. So all these very well defined exoplanets that TESS will discover can be followed up with other important space telescope and ground telescopes. And also very important is that TESS will provide what is called the full frame images, which are pretty much like recording every star in the field of view, so up to 20 million stars every 30 minutes, sorry. So this is pretty much like kind of Henry Draper catalog for the stellar photometry, which means basically that all the data that TESS will find is going to be used for astronomers for a generation at least. So it's going to provide like a huge amount of data that astronomers can analyze for a long time. So these are pretty much the type of stars that TESS will look at. So very bright, and these are actually the planets. So this is the star magnitude, and these are the planets. So as you can see, there are many more bright and nearby stars. And then, so the main reason why TESS is going to be launched now, it's because so with Kepler we know that Earth planets and super Earth planets are very common in the galaxy, but we have a very low set of Earth and super Earth planets that we can observe with more details. And for example, we actually have only 2, or maybe actually as of now 3, small exoplanets around bright stars, which are like Kepler 21b and 55 Cancri E. So with TESS, we can really we can increase much more this pool of small Earth and super Earths. And this is, of course, you've seen this picture before, I think. This is really important because on the series of exoplanet telescopes and missions that we have done so far, TESS is really like a key in the chain of the next following exoplanet missions. So for JWST and then WFIRST coming up later. And all of this big effort is very well spread all over the world. So it's a common effort with the scientists from all over the world. So we are collaborating with scientists and engineers from all over the world. And this is